This video is about operational amplifier circuits. But the simplest operational amplifier circuit you can have is the buffer or voltage follower, where the output follows the input. The inverting amplifier circuit looks like this, and a lot of circuits are based on this. And for the inverting amplifier circuit, then the output equals minus RF over RI times Vn. That minus sign indicates that the output is inverted from the input. So, here's what that circuit looks like with a gain of 10. You'll see we have plus and minus 12 volt supplies. So if we zoom in, we can see that here we have the input voltage goes from 400 millivolts to 600 millivolts. So when that gets inverted and multiplied by 10, that means the output goes from minus 6 volts to minus 4 volts, because the 400 millivolts has become minus 4, and the 600 millivolts has become minus 6. Now at high frequencies, the frequency response, the gain decreases. This is called roll-off. So here we can see, if we want to look closer, here's what it looks like. So we can see that the gain stays the same up until we get up to about, this is 10 kilohertz, 20, 30, 40. At about 40 or 50 kilohertz in this case, we see the gain starts to drop off. That's called roll-off. The summing amplifier looks like this, which is, as it suggests, to sum the voltages on these two inputs. So again, the output is minus RF times V1 over R1 plus V2 over R2. Again, the minus sign means the output is inverted from either of the inputs, and the proportion of the inputs that are added depends on these two resistors. And this can be extended to as many inputs as you'd like. The non-inverting amplifier looks like this, where the input goes in on the non-inverting input. And so the output is 1 plus RF over R1 times Vn. You'll notice there's no minus sign because the output is not inverted. That's why it's a non-inverting amplifier. And as I said, the input goes on the non-inverting input, which again is to indicate that it's a non-inverting amplifier. The differential amplifier looks like this, so that you have two input voltages, V1 and V2. V1 goes into the non-inverting input, V2 goes into the inverting input. So, not surprisingly, the output is proportional to the difference between V1 and V2. Now with four different resistors, then you get this fairly complicated expression. If the resistors are paired, then we get this, so that the output is proportional to the difference between V1 and V2. So, all of these circuits that follow are based on the inverting amplifier circuit. So here's the integrator circuit, where we've replaced one of the resistors by a capacitor. So the output is the integral of the input over time. So the output equals minus 1 over RC times the integral of Vn dt. Often you place a large resistor in parallel with C to avoid saturation, because since this is integrating the input voltage, if there's any constant DC component to this voltage, then over time that will make the output hit the rails. In the differentiator circuit, the capacitor has replaced the input resistor on the inverting amplifier, and so the output is the derivative of the input over time. So the output is minus RC times the derivative of Vn dt. In a logarithmic amplifier, a diode replaces the feedback resistor, and so now the output is related to the logarithm as the input. So the output is proportional to minus the log of Vn. For an exponential amplifier, the diode replaces the input resistor, and so now the output is related to the exponential of the input. So the output is proportional to minus the exponential of Vn.
Đấy thì bảo là cái ghế này nó không hàn liền mà nó không bê dịch chuyển được.
The same rejoiced theme of Govinda. Govinda would be played on a game field spread over an area of 14 meters by 13.5 meters. The game field consists of two separate areas. The outer area, Pacific blue in color, is called the manual area. The inner area, green in color, is called the autonomous area. The autonomous area consists of squares made up of grid lines of size 500 millimeters by 500 millimeters, except for the central tower area. The tower-like structures placed at all corners of the autonomous area are called gopis, which symbolize the milkmaids. The pot or the matka and the cheese or the paneer balls are placed on top of all the gopis. The total height of the gopis with the pot and the cheese is 750 millimeters from the ground. There are two side towers in each half of the autonomous area with a bowl on the top, containing cubes of white butter. There is a central tower carrying a yellow butter cube symbolizing the handi. There are four rectangular pockets on the game field called the baskets or tokeries. Red baskets are for the red team and blue baskets are for the blue team. The pot and the cheese are to be deposited in these baskets. There are two manual machine start zones in the manual area located on opposite sides for the red team and the blue team respectively. There are two autonomous machine start zones in the autonomous area, one each for the red team and the blue team. There is a common area of 2000 millimeters by 1500 millimeters for each team. Points would be scored when pots and or cheese are transferred to the respective team's baskets by autonomous or manual machines. Points would also be awarded when yellow or white butter is picked up by an autonomous machine and is held successfully in the air. The team collecting the maximum number of points at the end of 3 minutes would be the winner. However, if a team picks up all the 3 butter cubes directly from the bowls and holds them in the air, it will be declared Govinda, the winner.